In 1994, Peter Shor at Bell Labs proved a quantum computer could crack widely used encryption standards, a result that set an entire generation of cryptographers racing toward what comes next. This week, 420 peer-reviewed papers and 316 funding events confirmed. The field Shor's proofs set in motion are all arriving at once. Post-quantum cryptography has crossed a significant threshold. A $412,000 NSF Career Award for fault-tolerant quantum architecture arrived the same week as foundational PQC standardization publications, signaling the transition is now operational, not just theoretical. Intelligence agencies call it harvest now, decrypt later. Adversaries may be collecting encrypted data today, waiting for quantum hardware capable of breaking it, which is why the urgency around PQC migration is accelerating now, before that hardware exists. Separately, photonic qubits, quantum computing with particles of light, are showing renewed momentum this week, with fresh scholarly attention suggesting the photonics-based path could become a serious competitor to superconducting qubit roadmaps. And while quantum computing diversifies its hardware bets, synthetic biology logged the week's highest funding volume, 70 events, the most of any category tracked. Francis Arnold at Caltech won the 2018 Nobel Prize for directed evolution of enzymes, an idea colleagues said wouldn't work. This week's citation-heavy review papers frame synthetic biology in similarly retrospective terms: less research frontier, more deployable engineering discipline. The energy picture is harder. Fusion logged 80 papers this week, the most of any category, and much of it circles the same problem: materials. The bottleneck may be shifting from plasma confinement to whether reactor walls can survive the punishment. Research groups are simulating neutron bombardment on tungsten walls, compressing decades of reactor wear into models, because no material has yet been proven to last inside a commercial fusion environment. That gap is what the week's papers are chasing. AI has its own energy problem hiding in plain sight. The carbon cost of training large language models